Trower, and today I want to talk about my Dragonboard capstone project. So my name is Dave Trower. I'm a Java programmer, been a Java programmer since 2000. I'm also very familiar with AWS cloud platform, and I currently work for Enterprise Rent-A-Car as a Java programmer. So my idea is to create a small device with the Dragonboard, and the Dragonboard is hooked to an accelerometer. Accelerometer is a little device about the size of a postage stamp. And I want to be able to do what I call record a session. And what I mean is I want to record all the acceleration that the Dragonboard does, and it's for like say 10 seconds. And then that recording will go to a file, and that file will be stored in a cloud. So my idea is I want to build a small device, and the device will have the Dragonboard in it, and it'll run on a battery. And then I'll put the small device in an object that moves, and then when it moves, I'll be able to record its acceleration, its velocity, and its position. This will all be recorded, and then when it goes up to the cloud, we'll be able to look at the values. So an accelerometer is a little device that can measure the acceleration several times per second, and it does this in all three axes, in the X, Y, and Z direction. By keeping track of acceleration, you can also calculate the velocity, and if you keep track of the velocity, you can determine the position that something has traveled. So I thought this might make more sense if I show you a example of a recording. So I recorded the accelerometer just sitting on my desk for 10 seconds, and as you can see, most of the numbers are close to zero. We have the acceleration, velocity, and position. And the reason why they're close to zero is the accelerometer did not move. It was just sitting on my desk. So this shows us a couple things. The accelerometer is not perfect. If it was perfect, it would say zero for all these values. But they are close to zero, so I think the accuracy will be good enough for what I'm doing. And we also could see, to get interesting numbers, we need the accelerometer to move. So that'll be a later part of the project. So this is my design. We have the Dragonboard with the mezzanine on it. Dragonboard has the LCD and an accelerometer. They both share the I2C port, so I have a expansion so both can work at the same time. And I have a buzzer that is hooked to the D7. So all these parts are working together with the Dragonboard. One of the big challenges, like I talked about, is to get interesting data. We need to move the accelerometer. The accelerometer is attached to the Dragonboard, so that means we have to move both of them. This means we need to build a small device where the Dragonboard runs on a battery, and that means the small device will not have a keyboard or monitor. So this is the most important slide in the slide deck. This shows you what I've come up with. This is basically a three-tier architecture where tier 1 is a client program running on my laptop. Tier 2 is a Java program running on the Dragonboard, and tier 3 is a Arduino sketch. So what I've got here is I've got a socket connection from the laptop to the Dragonboard. This is similar to when you use your web browser to go to a web server. When you do that, you have HTTP. This is similar but more simpler. Socket connection has some limitations, that it doesn't support encryption, and only one laptop at a time can talk to my Dragonboard. But these limitations are okay. And another good thing about the just doing a socket connection is it's much lighter weight, and it's much easier for the Dragonboard to run. I thought about putting a web server on the Dragonboard, but I thought that might overload it. And you can see this part that says jar file. A jar file is a Java archive, And basically what it is this is code that was given to me by the people that made the LCD and the accelerometer. And with the jar file, my program can talk to these two devices. So with this architecture, everything can talk to each other. Now, like when you have your web browser and you want to go to, say, Coursera, you have to type in Coursera in the browser for the address. In a similar way, I have to type the IP address in order to make this connection. So one of the first problems I had to solve is to figure out how would I know the IP address of my Dragonboard if it didn't have a monitor or keyboard. And the solution I came up with is when the Dragonboard comes up, it puts the IP address to the LCD display. So that way I can see the display and I can start up my program. Now, I think this will make more sense when you see the actual program running. So this is my laptop. I'm going to run what I'm calling the client program. So this is a program that I wrote. And the first thing I have to do is type in the IP address. And if you can remember from what was displayed, it's 192.168.1.239. And I'm going to go ahead and connect. So I'm connected to the Dragonboard, and I'm going to do a little test, or I'm going to test the buzzer. So I hope you could hear that. So here is what just happened. I hit the button on my client program. It sent a message through the socket connection. The Dragonboard, it saw that message, and when it saw that the buzzer message, it sent a message through the serial port, and then the Arduino sketch saw that message and it hit the buzzer. So this might make more sense if you were to actually look at the code. So I have all the code here. So if we go to where it says client, and we look at the test buzzer listener. So this action performed, this is what runs when I hit the button that says test buzzer, and you can see it sends the word buzzer to the socket connection. So it's sending the word buzzer to the Dragonboard. You see what the Dragonboard does, we have to look at the code under server, and we look at the file called server, and you can see the server is looking for about 10 different commands. One of them is buzzer, and when it sees the command buzzer, it runs the method buzzer, and if we look at the method buzzer, it's going to send to the Arduino buzzer on, wait 1 second, and then it's going to send buzzer off. And finally, if we look at the third layer, this is the Arduino sketch. You can see the buzzer is hooked to 7, so this is D7. You can see we set the buzzer to output. And you can see we're reading the serial port, and when we see the word buzzer, we see if it's on or off. Buzzer on or buzzer off. If it's on, we set the buzzer to high, and if it's not on, we set buzzer to low. So that turns the buzzer on and then off. And that shows the complete it shows that complete connection from client to the Dragonboard, and then up to the Arduino, and then to the buzzer. So the next thing I had to do is, since there's no keyboard or monitor, I had to come up with a way for the server on the Dragonboard to start up automatically. There's something called cron tabs, and cron tabs is something on Unix, and you can have it set up so it starts automatically. So if you look in the cron tabs directory, there's a file called Lenaro, and that is the permissions. It runs Lenaro with the permissions of the Lenoro file. It runs with the Lenoro permissions, and then that Lenoro script, what it does is it runs a Python program that gets the IP address. It starts the Java program called server, and then the Java program reads the IP address and it writes it to the LCD display. And since this is in the cron tabs, this starts automatically. I don't have to do anything to start it. Just turn the Dragonboard on. It automatically starts server, and then I can talk to it. So let's look at another thing that the program can do. So we can talk to the accelerometer by just hitting this button. So now the accelerometer is getting values, and it's just passing it back to us. And as you can see, most of these values are close to 0, and that's because the accelerometer is simply sitting on the desk and it's not doing anything. Another thing I can do is do what we call make a recording. And when I make a recording, what it does is it's going to get values from the accelerometer for about 10 seconds, and then it's going to take those values, store them in memory, and then when it's done storing them in memory, it's going to write them to a file. So when it's done making the recording, there'll be a file on the Dragonboard. And now if we go back to our slideshow, so it's going to be hard to see the file on the Dragonboard without a keyboard or a monitor. So we have another program, we have another option that I can tell the Dragonboard to upload the accelerometer to Amazon, and I'm going to do that now. I'm going to go ahead and say upload files. And this will just take a few seconds, and this will tell the Dragonboard to go ahead and upload the file up to the S3 bucket. And if we look on Amazon, do a refresh here. And you can see that it has uploaded these files to files up to the Dragonboard. It is currently New Year's Eve, about 4 o'clock, and you can see it checks to see what's on the S3 bucket and what's missing. So it uploaded these 3 files, and so these files are now up on Amazon. And we can actually go in the other direction by saying download files. So when I download files, these files that are on Amazon, they will download to my laptop. And if we look on my laptop, you can see it has downloaded the new files. So that is, I think, a good Internet of Things architecture. Here we are, each computer is taking advantage of what it's good at. The Dragonboard is being mobile and being able to connect to devices, but the actual of studying of the files can be done on the laptop, where the laptop has Microsoft Excel, where we could do good analysis, including things like graphing. So I think this is a good Internet of Things architecture. And I encourage you to go to gladshire.com. That is the website for this project. On this website, I do have a sample acceleration file that you can download. I've got a a link to the slideshow, and there is a link to all the source code. So you can see all the source code that I have created. So I encourage you to go there. And then finally, there are three phases to the project. We have already gotten to phase 1, which is I can make a recording and upload it to the file. Phase 2 is to make everything mobile, so the Dragonboard will run on a battery, and I'll build some kind of device to kind of hold everything together. And then finally, phase 3 is going to be accelerate, the accelerometer. I'm going to have the mobile device on some kind of device that moves, and we will move the accelerometer and get more interesting recordings. So that is my idea. Again, will come back when we get to phase 2.